Hello everyone. Today we are going to discuss about the problem find all the people with secret. It is one of the hard questions on Leetcode, but if you know a little bit about disjoint set, it is way easier and it does not require a lot of coding if this part of code is understandable for you. Okay, so let me just give you a quick info of the problem. So what it is saying that the person 0 have the secret, and this person 0 will share the secret with the first person. The first person can be anyone, it could be 1, 2, 3, anyone. So in zeroth time or in no time, there are two people who know the secret, the person 0 and the person first person. Now, what we are asked to do is that we are given a meetings array, and in here there is a time that is given to us, and we are saying that there are two people who will have meeting at this time, and during their meeting they will share the secrets with each other. So if one knows the secret, he will share it with two. If two knows the secret, he will share it with three, and so on. Okay, and the one thing which is important to mention over here is that it will happen instantaneously. That is, if one have shared the news or shared the secret with two at time 5, and let's suppose at the same time 5 2 is having a call with 3 as well, then 2 will pass on the secret to 3 as well. So it will not be like it will it will take some time for a person to share it with the other person. No, it will happen instantaneously. So if at any particular time a person is getting the news, it will share that news with all the other people with whom that other person is having the meeting with. Okay, so if you think a little bit about it, you will realize that it is a classic disjoint set problem. We are saying that if 1 and 2 are connected, and if 2 and 4 are connected, and somehow 2 is getting the news, that means 2 and 4, the other node or the other set that we have, will also get attached to 1. This is what disjoint set is about, right? We are doing the union. That's what union is about. So I'll give you a quick demonstration, I'll give a quick walkthrough of how disjoint set actually work. I'll not go in deep. So in disjoint set, we have a parent. Initially, each node or each person in the meeting, we know that there will be total n people or n minus 1 people in a meeting. So each one of them is their parent itself in the very start. Okay. And whenever someone asks that find me the parent, we will just use this parent dot get node to find the parent. And if we know that someone else is the parent of the current node, we'll keep on going to the parent node until unless we find a value which is parent of itself, which is the ultimate parent. So this find parent gives us nothing but the ultimate parent of a node. And when it comes to the union, in a very simpler term, I would say we are making one person the parent of the other person when the union is happening. Okay, and in the end, in the D union, what we are checking, give me who is the ultimate parent of the person 0, that is you parent, right? That is the ultimate parent. And now I'm checking for all the other presented nodes, is their ultimate parent also you parent? If it is not, then just update their parent to the previous parent, that was themselves itself. Okay, whatever they were, like 2 will be the parent of 2, 3 will be the parent of 3, and so on. So update the parent back to whatever it was earlier. If they are not the connection or not connected to 0 at the end of the day, this is what we want, right? Anyone who is connected to 0 or anyone who is connected to the parent of 0 should be visible at the end of the day. That's what we are checking at the end as well, that give me the ultimate parent of 0, and loop over all the values that we have and check if anyone have the same parent as our ultimate 0 parent, then just keep on adding them to our answer, and that's all. So this was one part of the code, right? Now the second part comes, that how we will do the union. So one thing to keep in mind over here is that this could be in any order. Time 10 values can be given at the start, and then time 5, and then time 8. So it could be in any sequence, right? But here the time matters, right? Because let's suppose at time 5 the transaction is happening, so whatever that have happened at time 2 does not matter. So what I'm saying is, um, let me give you a few cool examples, if I can. uh, let's suppose 0 have given the knowledge or given the secret to the first person, that is 3. Okay, I'm giving some random example. So let's suppose at time 1 there are two conversations that are going on, that is 2 is talking to 4 and 5 is talking to 6, right? And at time 2 the next conversation that starts is between 2 and 3 and 1 and 2. Fine. So if you see, there is no sense in adding these values to our ultimate parent values. Why? Because as of now the only person who knows the secret are 0 and 3. 0 and 3 are connected. That's the first thing I did the union of 0 and 3, 0 and the first person, right? And now what I done, I have sorted it on the basis of time, so that time 1 can get picked up and then time 2 and then so and so on. And I'm doing a small thing where I am picking up all the arrays that will have same time, all the combination that have the same time, and I'm doing their union. So in here what will happen, 2 will get 2 will get connected to 2, 5 will get connected to 6. Fine. And we will see that is any of them have the same parent as 0, that is 0 himself. So it will say no, none of them are parent of, or none of them have ultimate parent same as 0. So in that condition we will de-union them. So what does the de-union means? Making the parent back to 2. So this is 4, right? So that means making them back to themselves. So 2 will point to itself, 4 will now point to itself, 5 will now point to itself, 6 will now point to itself. 4 will no longer be pointing to 2, 6 will no longer be pointing to 5. So why this de-union was needed? So that the future transactions are not impacted. This user 2 will get the news at time 2. So whatever meeting that the user 2 is having at time 1 is unnecessary. We do not need to track it. That's why we are doing the de-union. And when we are saying de-union, I think you can't see my screen over here, but when we are saying the de-union, we are saying setting the parent back to themselves. Okay, so that's what we are doing. So in the next run what will happen, we will now be at time 2 and we will see, okay, this entire thing will get removed. No one is pointing to anyone right now other than 0 and 3, and we will say 2 will now get connected to 3. That's what it is happening. 1 will now get connected to 2. So the moment 1 got connected to 2, that means it's a disjoint set, right? We know that 3 is already pointing to 0. That means this connection of 2 and 3 basically means 0 and 3 was already connected. You are saying connect 2 as well to whatever 3 was pointing to. So 2 is now also pointing to same 0. Okay, and then the connectivity of 1 happened. So initially there was nothing that 1 was pointing to, but now it will point to whatever 2 is pointing to, that is 1. So we will say all 3 of them will have the same parent as 0. So when we go ahead with de-union, none of them will get removed. It will say yes, all 3 of them will have the same parent as the same parent that the 0 have. So we didn't did any de-union, and at the end of the day when we are reading the same thing, that if the ultimate parent is same for all, just keep on adding it. So at the end of the day you will see we will be returning 2 0 1 2 3 and all the values. So that's how it is working. The important point here is to do the de-union. Okay, so this is what the de-union is. So if you're familiar with disjoint set, you will see it is pretty easy. We just have to figure out the same time zones. We have to pick them up, do their union, and de-union them based on if they have the same parent or not. That's it. There is nothing else in this code. And if we quickly talk about the time complexity, it will be the sorting itself will take n log n time, where n will be the number of meetings that we are going to have. So let me name it as m. The number of meetings will be m. So the sorting itself will take m log m. Okay. Let's see what else. This disjoint set, if you're not aware, it's a constant activity. It doesn't take any time. It's a constant time complexity function. So this will take off one. We do not have to worry about it. Now we are traversing over all the meetings, and this, you might say that this is a meeting in itself, like this is a while loop inside a while loop. But if you see it carefully, we are basically incrementing our I based on our values, and this will basically, this entire while loop will have each block of meeting at once, and this while loop will take O of m and not O of m square. Why? Because the internal while loop is not a nested one. It is just a complement to the upper while loop, which is incrementing the values within inside of it if needed. Okay. Secondly, the union will take no time. Okay. The addition and all will take no time. Nothing will take any time. And the D-union will also take no time. So the while loop just took off m time. While adding it inside my array as well, it will be a constant time complexity. But we are reading through all the values. Correct? All the values we are checking if they are same as the parent, like if their parents are same. So at the end of the day, if you read it carefully, I don't know what is this, but yeah, the ultimate time complexity will be m log m plus n. So in front of m log m, you can just ignore m. So at the end of the day, it will be n plus m log m. That's it. This will be a time complexity. If we talk about the space complexity, we are using a disjoint set which is using parent and size. Parent is will be of size n. As you can see, size will also be of size n. So it is of n plus of n, and we are using and O of n again to save the value. So it will be of n plus O of n plus O of n, that is ultimately equals to O of n again. So this is my TC, okay, and my SC will be equal to O of n. That's it. I hope this helped you. I will share this code snippet in the comment section as well, and this is a very good problem. I would say everyone should try it if they're comfortable with disjoint set. You will learn a lot. You will see how you can manipulate functions, how you can tweak it, because disjoint set, these things will always remain constant. I swear I didn't made any changes in any of these functions. The only thing, either you need to add some array list, or you might need to introduce some new function just to check some nitty-gritties. So disjoint set is very flexible when it comes to questions which are kind of a dynamic problem. We don't know what is coming next, and they might be connected to my current situation. So what if I'm at position X and something is going to be coming in the future, but I'm not sure if it is going to connect with X. So in such dynamic graph problems, disjoint set is a very interesting and useful and very time efficient data structure to use. Thank you so much. I hope this helped you. Thank you.